now, and welcome to this first video of solution to the unsolved problem. Today we will solve the Riemann hypothesis. Which as simplified by Lagrange state that there's sigma n is less or equal to hn plus e to the power hn in hn. Now, this is what the Riemann hypothesis asks us to prove. The Riemann hypothesis states that sigma n, this asks us to prove that this is true for all n coming from the set of real numbers. Now, you have such a statement to prove. Now, let us try to prove it. We can see that sigma n is equal to the summation of all the possible divisors of n, which means that it's a summation, meaning that it's starting from 1 to 2 to 3, 3s, up to n1 divided by ns. Now, our hn is the summation of all the possible numbers, all the whole numbers from 1 up to n. All the possible whole numbers from 1 up to n. These this is sigma n and this is hn. Now we can represent sigma n to be equal to the summation from n equals to 1 to infinity of 1 divided by ns. Why n equals to 1? N equals to 1 because 1 is a common divisor. You and I know that. Why? 1 is always a divisor, and hn can be represented as the summation from n equals to 1 to infinity of 1 divided by n. Now, we are having such a thing. If you now try to substitute these summations into our statement that we call Pn, you will be having this n equals to 1 to infinity of 1 divided by n to the power s. Now, less or equals to the summation from n equals to 1 to infinity of 1 divided by n plus e to the power the summation of n equals to 1 to infinity of 1 divided by n, length of the summation from n equals to 1 to infinity of 1 divided by n. Now, let us try to prove it. We will prove it starting with a digit. Let us take any digit, like 1, so that it should be very fast. Let us say p of 1. P of 1 will be the summation from n equals to 1 to 1, which is the same as 1, less or equal to the summation from n equals to 1 divided by 1 plus e to the power the summation from n equals to 1 divided by 1, length of the summation from n equals to 1 to 1 divided by 1. Now, we know that the length of 1 is 0. Now, it is meaning that 1 is less or equal to 1. Our P1 is true because 1 is equal to 1, as you all know. Now, let us try to bring out small knowledge here. Now, you have sigma n less or equal to hn plus e to the power hn ln of hn. Now, sigma n is almost the same as hn from our summation. We can see that sigma n is almost the same as hn. The only problem will be this. The only problem which can tell us if the Lagrangian version of the Riemann hypothesis is true or not would be the value of e to the power hn in hn. Now let us try to reason small. Now e to the power hn in hn, if you want to see ln of decimals, means that ln of one of numbers like ranging from 1 greater than ln of these are negative. So we can see that for all n with n belonging to the set of real numbers and n greater than 1, greater or equal to 1, this sigma n less or equal to hn plus e to the power hn ln of hn. We can see that if we try any number 1, 2, 3, 4, 5, 6, even 1000 here, the only we will be having this is less than this. So from here we can conclude that our Riemann hypothesis is true, because e to the power hn will always be positive, and since hn is already greater than sigma n, and you know that if this one is positive, it will go and add further to this one, making this one more or less than this one. So our Riemann hypothesis is true. Our conclusion from this first video will be that Riemann hypothesis is true. Thank you very much. I'm waiting for many comments, and we shall continue together next time. Bye bye.